Hello and welcome back to Compiler Programming. In this video, I thought it's time for us to get a bit more serious about sizing the different values, or more particularly the descriptors. So I'll just go through the whole code and start figuring out what will be the right way to go about it. And I'm not right now sure about it. We have basically two options. Since our operands already have byte size, we can just either rely on operand byte size for all the sizing by moving these into the main value, or we can duplicate them. And as I said, I'm not entirely certain what is the right thing here. Like, do they always match? Do they is it okay if sometimes they don't match? Like, and what is the right way to do it? Another thing to consider is that right now our encoding function actually does not know anything about the descriptor or the value. It deals purely with operands, but it still needs to know their byte size. So I guess it's still important for us to keep it there. Actually, does it? Yeah, it cares about it for the rexw, and we also right now not supporting 16-bit instructions, which require a different prefix as well. So when we do those, we also need to add another check here. So all in all, encoding definitely does care about byte size, and descriptors do in different places. So I guess for now, what I will do is I will start adding it to both, but since I'm staring at these to do as well, let's start with this one to allow us to reserve more stack space. So let's do S32 stack reserve and see what actually breaks when we do that. So some stuff does break, which is fine. S32, good, and there is probably somewhere function return. No, we want function end. Function end. Yeah, that was what I was looking at. So here, and RSP instead of instead of 8, we now say 32, which again is not very efficient because now all of our functions become slightly larger, but all in all, it is a better way to deal with this. And now we need to increase our uninitialized value to be slightly larger. Okay, this seems to at least build. Let's see if we are passing. We are not, and we are probably not passing because we need more instructions to encode. So yeah, we have this sub immediate 8, but we don't have sub immediate 32. So let's deal with this. It's rather easy. We've done it multiple times already. Sub immediate 32 is 81 instead of 83, right? Yeah. Good, it's 81, it's still /5, it's register memory, and it is 32. Okay, that's good. Let's try that again. We still did not succeed. Probably our add has the same value, and it does. So I assume it's gonna be the same 81, and indeed it is. So immediate 32. And great. This is okay, and I will even commit this right away, saying use 32-bit immediate for stack reservation. Okay, so one less thing to worry about. Now let's get back to the top and look at the next thing. And the next thing is something that is not going to be so easily fixable. In particular, this has to do with our descriptors. And right now, if I look at the descriptor stuff, which is in here, we have these descriptor types, and we only know size of some of them, right? So we know void is basically, depending on how you look at it, unless it's a pointer, it's nothing. Then integer right now is always 64 bits. Pointer is always 64 bits, which is actually how it's supposed to be. Fixed size array, we don't yet have a way to calculate its full size because we have the length of the array and the item descriptor, but nobody actually multiplies those, basically. And function is the same as pointer, so it's also 64-bit, right? So the only real outlier right now is an integer, and this is what we are going to focus on for this video. And I think I will just start by doing something similar to what we already have for the function stuff. So we will say descriptor integer. Who knows if we'll add more stuff to it. And integer will have byte size. Okay. And now here we say descriptor integer. Good. Another thing we probably want to have is a way to figure out what is the size of each of the descriptors. So let's do U32 and say descriptor byte size, right? And it will accept a pointer to descriptor and return to us what we want. Now we need to add an implementation of that. Let me think where I want to put it. Let's just put it right here at the top, to be honest. Okay. So what will it do? It will switch on the descriptor type. Oh, first of all, we can be good to ourselves in the future and actually assert that we got the descriptor. Then we say descriptor type, and now we need to have those types. So let me just copy paste that. It's gonna be like this, and a bunch of copy pastes, right? Okay. And done. Great. Now we can also add default and assert unknown descriptor type, right? Just so that when we add a new one, we right away know that we messed up something. Okay, and right now for the void, I will say return 0. Okay, probably shouldn't have done break, but rather return everywhere. But we can fix that right now. Okay. Here I will just do 8, and we can, forgot to have a colon everywhere, like so. Now pointer is the same as function, and it is 8. Can merge those two. And the size of array is recursive when we say it's descriptor byte size of descriptor array item times descriptor array. What's its item count or something? Oh, it's called length. Okay, that's good. And this is the one again that we need to fix, and since we added this, we can use it right away. We say it is descriptor integer byte size. Good. So now we have that. It should not really change anything. Let's try to build this stuff. Conversion from S64 to U32 is not possible. Where is not possible? Yeah, here. I mean, yeah, let's just cut this for now. So I honestly don't think that I will support more than 4 or more than 2 gigabyte or 4 gigabyte arrays anytime soon, especially ones coming from static compilation. So like, let's just ignore this problem and say just cut this. Okay, in reality we'll never get to here, but C doesn't know that. Okay, so we now have that byte size there, but we now need to change the descriptor stuff. So the first thing would be to change the descriptor integer to a bunch of different descriptors. And right now they're not really signed or unsigned, they are just integers, but I think it's better to treat them as signed. Okay, so we have S64, we have obviously 32, we have 16, and we have 8. Since we use this in a bunch of places, it's gonna start blowing up right about now when I try to build. And yeah, as you can see, there is a lot of errors. But this is fine. This is why we are doing this. Now it's going to be actually much better, because here we say, oh, it's an S8, right? When it's a char. Here, integers are kind of interesting, actually, because I believe depending on where you use them, they might be different size, but right now just say that integers are 32 bits for our purposes. Okay, that is fine, and this is fine. Okay, this is the next thing. Next thing is this. Make an entity, descriptor integer. Now it's going to be descriptor S64. This is okay, and this is an interesting stuff now, because these ones I guess are also 64. Actually, yeah, they are all 64 here. Okay, equals reserve stack. Yeah, I guess it's also here as 64. Make is non-zero. Well, here actually the argument should be 32 bits and not 64. Okay. These are all 64. This one is yeah. So 64. Okay. And this is actually different, but it's not really used, so it's not gonna cause us any issues, I believe. Okay, we still have some stuff. Line 3 to 8. 3 to 8. Descriptor integer. Well, I guess that should be 32 then. Okay. I'm pretty sure things will start breaking now. But they don't, probably because we mostly don't use this byte size anywhere. So let's again save current state and use this here. What did we call this nice function? Descriptor byte size. Descriptor byte size of descriptor. We can actually make this const because we are not changing the descriptor inside the function anyway. Okay. That's fine. But in reality, this is not also not fully correct, because here we should be let's just do it right away. We essentially need to align our stack to 16 bytes. So that means that like whatever is the value that we are reserving, it's gonna be like the final alignment needs to be divisible by 16. Actually, I'm not really sure if all of the values need to be at the right alignments. Probably not. It's probably that just the stack pointer is expected to be at the right position. Let's check this with Compiler Explorer. I'm actually not entirely sure what is expected here. And the way I'm gonna check this is by doing this and seeing how much it actually reserves. No, Siri, I'm not talking to you. This Microsoft version is so slow, so let's just go to official one and do 8 and in 8, and let's just say okay. So what I'm interested in is how much stack space it reserves. And RBP, move RBP, RSP, RBP minus 24. 24 is 32, right? I believe so. So if you say hex 24, actually I'm not too sure that here it's hex, probably not. Probably it is, no, it's actually decimal. So let me think about this. If oh, this is actually very big reservation. Why are they reserving so much? So it reserves 24 bytes, but then it addresses it this way. This is interesting. So let's actually try this out. So what happens? Let me put this back because what I want to check, this is how it was before, and I want to check if we can actually do alignment at the end instead of in the beginning. And that would be in function end. How would that look like? So we say we reserve 16. Yeah, let's not do that. And instead, we want to have something like S32 align align bytes, I don't know, align number, whatever, align, and it will get a 32-bit number, and it will get alignment. And the idea is that, for example, we will get something like 20, and we say that alignment is 16, and we should get back 32, right? And the way we can do that is we convert the number to a float, then we will divide that float by 16, or is it like sealing? Can we seal? Yeah, okay, there is a sealing function. This is exactly what we want to use. So we say return double of number divided by alignment. Then we do ceil, and then we multiply by alignment. Right? That seems like what we want to do. And then obviously we need to cast this all back to S32. Okay. So we say we want to align the reserved thing to 16 and add this alignment from call, right? Because this is static regardless of what we have elsewhere. This is just coming from the fact that when this function was called, they pushed the return address on the stack, and that return address is 8 bytes, and that causes stack to be misaligned. Okay. Which library do I need to bring in? It's called math.h. We can do that. Let's see what happens. Okay, so this is interesting. We actually get one error, but so let me think about it. I guess the reason we get an error is because now we don't have that yeah, basically all of our variables that we created are now a bit off in the stack, and this is not really nice. So my guess is what is happening when we do reserve stack, we just add, let me mark this, and let's go to reserve stack. Yeah, so when we do this, we just say that operand is existing at stack reserve, and this is fine, this is correct, except that now that we do that stack alignment there, we mess up with this encoding, and this is kind of interesting. Oh, actually, it's not just that. It's also, we need to say function stack reserve plus equals byte size. But I think it will still do wrong thing. Let's check. It doesn't, but I think it doesn't by accident, sort of, because if I understand correctly, like if I add another variable to this function, then it's gonna explode, and we can test that. So right now we are kind of very fortunate that we create exactly two variables of 8 bytes each, and because they are 8 bytes each, everything is great. But I think if I do something like this, then everything is gonna break. It doesn't. That's very, very peculiar. I wonder how it's that. What if I do this? Still works as expected. Okay, maybe I'm misunderstanding something. Let's keep it as is for now, I guess. Actually, no. Yeah, it's gonna work fine. It's gonna work fine, regardless, because yeah, I'm thinking of the wrong thing here. It's gonna be fine. Good. So we yeah, we don't actually use the descriptor size. Maybe that's why it was working. But if I'm saying that it's gonna work fine, it should still work fine like this. And it does. Let's check, where is that function make increment. Let's double check that I'm not misunderstanding. We don't need to save this value to stack. So let's check. Okay, everything is fine. Good. Now we need to check if we are misusing the sizes elsewhere. Okay, check values, deal with immediate 64. Yeah, that's actually even more than immediate 64. The whole thing, so this to do is kind of two stages actually. One stage is about different sizes for stuff that fits into the register. Another one is for different sizes that doesn't fit into the register. I guess we right now don't care about this thing in particular. This is fine. This is fine. Choose the right extension based on the size. This one we actually should fix. So let me get the current thing right. And we will try to fix this. Okay. So currently we are calling this with 32-bit operands. And I guess if we look at the divide, more than just 64-bit operands, we also call them with immediates that are of the right, of the same sign. So let's first check that it works with negative number, and it doesn't. So let's first figure out what's up with that. We don't need this for now, but we do need our debugger. Def environment 2. It's called like this. Let's check this. Okay. Let's just run this and see what happens. Yeah, so it's the same integer overflow thing as it is in other places. Okay, let's recheck what is the assembly that we generate for this function. Go into here. Yeah. So this is interesting. It should be CQO, right? Instead of CDQ. Where is this stuff? Yes, so it definitely does not choose the right encoding. And the reason it doesn't choose the right encoding, so let me bookmark this. We don't need this bookmark anymore. Instead, we want to have one inside divide, which is somewhere hidden. Okay. So what is happening here exactly? Oh, yeah. Actually, this is very, very interesting. The problem is that CQO or all other instructions, they don't actually accept an operand, but we still need to size them somehow. And we are not ready for that at all. I wonder what to do about this. We could have like explicit size thing in the instruction. I guess that would work. Well, we need to add something like this. Let's just do this. So U32 explicit byte size, and now we need to add it here. So CQO is explicit byte size of 8, and other ones are not. But now we need to actually split them up into separate instructions, because otherwise they will not really work. Stop this. Okay. So this will be CDQ, and we want also, and CDQ is 4. And then like this, and like this. This is going to be 1, or actually, yeah, I guess it is 2, right? It's word. Signed extent of AX. Yeah, AX is 16 bits. Bit 15. Okay, yeah. So it's actually explicit byte size of 2. Now we also want to do something like this. And say if coding explicit byte size is 8, then we again add rex w. Okay, let's check this out. Okay, so this works. Let's confirm that it was correctly encoded here. Ding, ding, ding. Okay, yeah. So now it's correctly CQO. Great. This is fine. Let's store this version. But what we were actually doing is checking if we can divide 32-bit numbers because the sizing is what this video is all about. So let's say it's now S32. It's a different function type. And everything is different here. But the result is basically the same because it's still within the right size. And we need to add a bit more stuff. So we need to have this type definition. Divide function, too many actual parameters. Yeah. Okay. Well, let's try this out. And now it does not work. Let's look at the generated assembly before we dive deeper into this. Okay. So if you notice now, instead of RDX and RCX, we have EDX and ECX, which is what we expect. This is completely fine. But I'm more interested in our code. This is kind of funky. Why are we moving RDX into both of these places? What's going on there? So the first thing that we do is we move RDX and stack. Oh yeah, and actually this should not be RDX. This is the yeah, this is just wrong because for our temp stuff we always want to use descriptor S64 because we are saving a register and not a particular value. We don't really care like if the actual value that was stored there was 8, 16, 32 or 64 bits. It's just about the register. Okay, so descriptor S64, and then when we restore, yeah, here it's actually fine. So let's try that again. Incompatible types instead descriptor. I should learn how to spell. We do have descriptor 64. This is what I'm passing into here. What is the problem with the reserve stack? Okay. Don't know what was it. Maybe I forgot to save somehow. Let's try to run tests. They still do not pass. Yeah, now we have to deal with this move. And here, actually, we wait. What is happening here exactly? Divisor. I'm confused. I'm really, really confused. I believe it should be a operand. What is divisor? Divisor is a reserve stack. Okay. Shouldn't this be like B? Yeah, it should be B. Because this is what we divide by. How is this working? I wonder before. Let me check this version. Still no dice. Okay. Let's look at what we are doing. So we are moving. So we are saving our dx into. So this is this move. That totally makes sense. Then we put the first, like our dividend, I think it's called, into into a rex register, which is correct. Then we put our second argument on a stack at rsp plus 8. That is also fine. And then we are actually, we are saying we are dividing EAX by the stack stuff. Can I do something like this? What if I do RSP plus 8 and cast it to long? Will that work? Like this? So when in doubt, add more braces. That does not look at all like what I want. I wonder what's going on here. So what is and the stack? I'm confused. EAX. All of the registers have weirdly strange values. Because we have not actually got to there. So yeah. Now it's much better. So maybe my stuff with RSP plus 8 was actually fine. And then I can do like long star. Yes, okay. So seems to me like this is perfectly fine. And what if I do int? Still fine. So okay. What is the result? Sorry, I cannot do hexadecimal. It's... Did it do 64-bit version? Ah, okay, yeah. Now we actually need to do correct extension because I think it extended our 32-bit value instead of the right one. So here we need to do a switch on descriptor byte size of what? I guess of our divisor, or no, of A. Okay. So we need to check what is the size of these, and depending on that, choose the encoding. It's kind of unfortunate, like I didn't know that such instructions exist, so I might have to rethink how the encoding is actually stored, but for now we can just fix this here and say case 8 break 4 to CQ CVD, and then default assert unsupported byte size when dividing. Okay, this is fine. Good. Well, let's check that again. And now it works. Cool. And now we can get rid of this to do, which is what we wanted to do. Yeah, now we actually need to add another to do here because I noticed like we don't need to, it doesn't really hurt us here much, but we ideally we don't want to always hardcode arrayx here. Instead we should have like arrayx or a register for byte size or something like this. Like when we do a move, we need to make sure that both operands are the same size unless this operand is something like if of 32-bit immediate size or something along those lines. So make a move version that supports, that checks size of operands. Okay, but this is a separate topic altogether. Like just getting move to work correctly will be probably several videos in and of itself. Let me look through the rest of the code and check if we have anything funky, and indeed we do. So we have function arg, and here we need to do a slightly different thing. First, let me store this version. In here, we actually need to say that U32 byte size is descriptor byte size of what? It's a descriptor byte size of descriptor. And then we need to say that we don't support byte sizes that are larger than 8 at the moment. That's good. And now that we have this byte size, we can change the operand, because right now, as you can see, like we are putting RCX, but what we should be doing instead is something like this: operand type register, and then reg is index is, or we can do RCX reg, I guess. And then byte size is byte size. Check if this is built. It does. And now we need to do the same stuff to the rest of this bunch. Basically, what's happening here now is, instead of saying that our arguments are always 64 bits, which they are not, we will now use the correct size for those operands, which is nice, and probably will result in a few breakages here and there, which we will now be fixing. Okay. And final one, R9, R9. Great. This is good. Let's run our tests, and nothing actually broke, which is very surprising, but I guess it's very nice. We can check one of the functions that uses 32 bits for the right thing. Yeah, I guess this one would be the right choice. Yes, function to call no argument. This one. Or not. No, actually, this is not the right one. But let me think. So actually is non-zero supposed to be S32 to S32, but we were assigning result to the wrong thing. So that's the one that we will look at then. Okay, I need to build that again. Actually, I need to run tests. And then I need to start this. Tink, tink, tink. Disassembly. I wish there was the way to say, like, step into. Actually, what happens if I do step into this call? Yeah, it doesn't really work. It kind of sucks that when I try to step into a function, it doesn't step into a disassembly. Maybe there is a setting somewhere that I need to check. I don't know. For now, I guess I'll have to do it manually, how I was doing it before. Okay. And it looks like now it's doing the right thing. So, not sure about this move. Maybe. This is how we are clearing the register. So I think this is fine. It might be better if we will be using the right size here as well, but I'm not certain. Then we set E, and then we save our AX. We compare again, and then we jump. And then we actually here it's also not exactly correct, right? Because we should be using the return value for the function to decide where we copy. So let's fix that. Where is our make increment? No, this is not make increment. This is 0. Where are you? Where is the 0? I'm a bit lost. 0. Wow, okay, it's actually the last one. Okay. Function return. Yeah, so what we should be changing is function return. And here that's actually should be S32 because this is what it returns. And now we want to change function return definition. Yes. So this thing actually needs to not have a hard-coded array x here, but use function descriptor returns. Now this is interesting. So right now the function doesn't actually know right away where it will return the value. So let's do it like this. So we say operand return operand, and the logic will be basically the same as in here. So we know that maybe we should later on merge these checks into something better instead of copy pasting this logic, but for now let's make it work. So we get this size of to return descriptor, or maybe this one like this instead, and then we use this by side and we use array x here, and then we say return operand. So left operand points to struct returns what? Which line? 296. So this one. Function descriptor returns. Returns is no. Returns is a value. I'm confused. What? Okay, whatever. It still works, which is great, but what I wanted to see now is that if we try to look into what this function does, that it will have correct size when it does move to return value. Let's check that. And now it does. So now, since we know that our return value is 32 bits, we correctly just overwrite the 32-bit version of the register. This is great. So I think with that we are ready to recap. Now our arguments are doing the right thing. We discovered this interesting thing with the fact that some instructions have inherent size that we need to deal with somehow. and I added this stuff, but I'm not sure that's the right way. And we also fixed the returns, which is really, really neat. And I think with this, we will be ready to start diving into much more interesting stuff or different stuff with hopefully structs and everything around this soon. But for now, that's it. Thank you very much for watching and see you next time.